They do. The first thing I'm going to do is tell you about a little tiny announcement, and it's actually it's just a little bit of good news. How about that? If you remember our first test that we had, I had accidentally and wrongly said it was worth 126 points. So if they were 3 points apiece, and there were 42 questions, it should have been 126. But remember, the essay was worth 10. So I had forgotten it's actually 136 points. So it's actually good news for you. So let's say you missed minus 20 points. Your original score was 106 out of 126. Well, now guess what your score is? It's 116 out of 136. So it bumped up a little bit. Get that? So if you only miss 20 points out of 136 points, it's a little tiny bit better than missing 20 points out of 126. Does that make sense to you? So if you go home and look at your test score, some of you who say, well, it says I had you didn't have a letter grade, but some of you who might have had a C plus might be a B minus now, but I don't know how I did that, but I forgot it was worth 136, not 126. So the good news is everybody's grade went up by a little bit. Yeah? That's a minor announcement today. All right, so what we're going to do real quickly is I put this on the Google Classroom, what it is you have to do, and I hope you can get a little excited about it, because if you don't and just kind of wait, you're going to have more error. You don't actually have to do it on the day of the equinox, but the closer to that day, you're going to get better results. Now, if you do have to think about, how am I going to make a vertical stick? So you have to really think about that. Is that a vertical stick? How do I measure the shadow? I mean, is the shadow a sharp shadow, or is it kind of rough, you know? How are you going to do that? And then you have this, and also, how are you going to do that protractor thing? You have a stick there, so how do you measure a sunbeam? So that's all part of the problem solving part of this. And so, again, it tells you on Google Classroom exactly what to do. So you have to calculate it three different ways. One is using the angle here with the protractor. Two, using the angle you get with trigonometry. And three, using the angle when you look up Greensboro's actual latitude. And so you'll have 3 times you find that this comes to the Earth. In this unit of measurement, we have this thing called standards. Which one of those is going to be our accepted value, our known, our standard? Which one's going to be that? The value you get using the angle at the top of the stick, the value you get by using trigonometry, or the value you get by looking up Greensboro's latitude and putting that in an equation. Which one's the standard? Which one? Yeah, the Greensboro, right? So then when you have to find percent error, then you know that you're going to use the Greensboro value that you looked up as your standard, your accepted value, like that. So even though I gave you probably more time than you needed, I saw some people even today that were going to set their stick out. You do have a problem with going out there for 15 minutes, because how did you know that was solar noon? And right, and used to be you couldn't look it up, but you can look it up, or you can put it out there and just wait till you get the shortest shadow. Is that correct? So, and sometimes you have to wait more than an hour for that. So you could look it up. I can't actually get you out of anybody's class or anything like that. So you're going to have to kind of do this the way you think you do it. If you think it's going to happen at lunch, you can go out at lunch. If you think it's going to happen during somebody else's class, and you ask them, hey, can I be out of class for 10 minutes and get a reading? You could do that. Or you can just wait till Saturday or Sunday and do that, do it on the weekend. So I gave you 2 different weekends you could do it, in case you don't want to do it like during the weekday, like that. Now, you and your partner, you do have to think about how to put this puzzle together, What am I doing? Why am I doing that? How does that work in here? How does this thing work again, at proportionality? And I want you to be able to do that. You can go watch the video game again if you wanted, if you wanted to. All right, so what I do now is today we're still in a concept called measurement, and I have back there on that table. I don't know if I have enough of them, but that's all I have. You should get one of each packet and then one of those pieces of wood. So if you want to go ahead and maybe the back row, second row, and then let's do that. And if I run out of pieces of wood, then maybe just a couple of tables might have to share, but I have almost enough pieces of wood. Okay, let's have 4 more people go down there. I'm going to wait, and I don't know. I said we have a test on Monday, next Monday, but I'm going to see how it goes. If things go well, we'll have it on Monday. If not, it's going to be on Tuesday, and I'll be able to tell you that pretty soon. So we would have our test on Monday or Tuesday over this unit, and 30 points of the next test are 3-factor label problems. And I didn't know if I had handed those back to you or not, did I? Yeah, yes. All right, so here's what I'm going to do. Flip these up. If they're not in class, just give them back to me. Okay, so everybody listen up now. This unit is not a big unit, and the thing you turned in yesterday, I still have a couple people that still didn't turn that in, so I'm going to wait and maybe grade that tomorrow. But that was about the history, a little bit about the history of the metric system, and you had a whole bunch of questions to answer there, and you'll get credit for that. And then we got into, before we started that, we did factor label, and that will be on the test. There'll be 3 factor label problems, and I'll probably concentrate on type 4 and type 5. Everybody got that? So you can say, you know what, I really know what I'm doing now. I'm going to bust those out. There's no reason why I can't get 30 out of 30 on that part of the test. And so I also had a student a few years ago who loved doing these. He made practice tests. And he was actually pretty good. He made it look good. Almost all his answers are right. I can't guarantee every single answer on here, but almost all of them are right. So this is like a little practice test. It's not for a grade. Nobody needs to turn in. Everybody see that? It's up to you if you want to do that. You said, I'm going to do that before I take the test. And that has an answer key in the back. Nice. Okay? And this doesn't mean it's everything. It doesn't mean it's everything. It just means that that's what he did when he did practice test. And then this is what I'm going to be using to kind of teach with, all right? So today, I'm going to jump all the way over today to this section. Let's see. Let's go to the section where it is. There it is. It's called significant figures. So I thought we'd do that today. So it's this page here. It looks like this one. We had this in chemistry class, and if you were to take advanced chemistry, we did it again. I had Miss Founds, her son, Michael. He was in my class. He's at UVA, and he already has his chemistry undergrad. They're paying for him to get his master's degree in chemistry, and some of the things he has to do is he has to teach first-year chemistry labs. And he was saying that, man, make sure Mr. Feeney keeps doing that thing with significant figures and accuracy and precision, because that's what it's all about when you first start chemistry, the first, couple of weeks back there. So anyway, excuse me. Do you remember this a little bit from 10th grade? All right, so here we have this unit on measurement. And you say, okay, what is a measurement? Well, a measurement is where we assign a number and a unit, isn't that right? And I think last year I may or may not have said this, but every measurement you can think of, contains three things. It has a number, it has a unit, and it has something else. Error. Now, every single measurement has error. Every single measurement has a number and a unit. Now, the reason why we have to talk that way in science is because we measure things. We assign a number, the best number we can come up with for that measurement. Now, they don't do that in math. Math just makes up a number. For example, a line is 5 centimeters long. They didn't measure it. They came up with that in their head with 5. And the 5 in math class is the perfect 5. 5.000, there is no error. There's no error in that 5 because it's a theoretical 5. So what about in science class? What if somebody says, I measured something and it was 5 centimeters long? Is it? I measured something that's 5 centimeters long. Is it? We don't know. And sometimes they'll say it was 5.0 centimeters long. Sometimes they say 5.00 centimeters long. In math class, guess what? What's the difference? In math class, what's the difference between 5, 5.0, 5.00? What do you think? There is none. Yes. Is that what you're going to say?
Yes.
All right. Sorry, Jeff. I should wait a little bit longer. But what about in a situation where you measure things? When is 5 centimeters not necessarily 5 centimeters? In math class it is. Yes?
Well, it's counted numbers and measured.
Counting numbers are perfect numbers. Counting numbers are perfect numbers. There's no error. But when is 5 centimeters not necessarily 5 centimeters? When it's measured. You see, if I give you a device to measure it and you say 5, what if I would have given you a better instrument and you say, oh, look at this. It's really 4.98 centimeters. Oh, yeah. So when is 4.98 not necessarily 4.98? When it's measured. What if I give you a better measuring tool? Oh, it's really 4.980011. You start getting that many figures, now you're talking about something that costs a lot of money. Now, you and I, our lives are not affected by measurements with that many sig figs. But are there people who do things like the people who built your cell phone? Do you think they might have been measuring down that low? Do you think the people that make computer chips, do you think they have to measure something pretty small? They do. You didn't. So our world does operate on people measuring even tiny things. So let's take a look. So what I'm going to ask you to do is significant figures, also known as significant digits, it's always a measured number. Everybody got that? It's always a measured number. That's why you'll probably never talk about this in math class. They don't use measured numbers. They use perfect numbers. Okay, so these rules only apply to measured numbers. A long time ago, I even had a little bit of this, and I didn't quite understand it in college. Okay. And most of the books back then had 6 or 7 rules about whether a digit was significant or not. I remember when I first started teaching, I was at, I taught Indiana before I came here, but I was at Grimsley here, first time I came to North Carolina, and the chemistry teacher says, I hate teaching significant figures. I work so hard to try to get the rules, and then I give them the test or the quiz, and it's like they forgot everything. And then I thought, well, and I saw very creative ways of trying to do sig fig, blah, blah, blah. And then it came to me that there's some reason why this is actually simple. This is actually simple. It's just a matter of, well, why was it not simple before? And every book I had ever read talked about rules that said, well, you're significant for this, but if you're this, you're not. And if you are this, you are, and you're not. And then you are, and then you're not. No wonder it was confusing. You had to remember about 6 rules. So even this thing I got out of a paper, out of a book, I crossed these out. I'm crossing out every rule that says when something's not significant. All you really need to know are 3 rules. If you're one of that, if you're a number 1, a number 2, or a number 3, you're in. So let's talk about what this is all about anyway. I can teach you how to play this little game here. It's not really a game, but I think when I was first teaching, that's what they were doing. They were playing a game. The teacher would give them 10 of these and say, how many sig figs? And, oh, you got 6 out of 10 right. Oh, what does that mean? You remember the rules or you didn't remember the rules, is that right? But I found out that what I really didn't like about it was that students had no idea why they even studied them. Why do you even study significant figures? And you don't study them in math. And so what I'm going to show you here is, all I need to do is, let me see if I have it here. Yeah, let's go here, 2 pages on. Let's go 2 pages back. And I have a rectangle here. Everybody see that rectangle? Take a look at the rectangle. Now, what I'd like to do is, I'd like to find out how long this triangle is and how wide it is, all right? So I'd like you to take your ruler, your wooden ruler, and find the side that only has about maybe 3 lines on it. Everybody see that? And so here's one of them, and here's one of them, and here's one of them, okay? Has everybody got it? Okay, now, just pretend that that's the best ruler you can get your hands on. Now, let's see if we can measure how wide this is, all right? Okay, let's try it. So I'm going to line this up, and I'm going to say, wow. Is it one of those? Is it one of those? Does it go from here to here? No, it's not 1, so it has to be point something, doesn't it? If this is half, that'd be 0.5, so what do you think? How much is it? How much? 7 of these? Or 0.7?
0.7.
Okay, so I'm just going to just write this out here. You think it's 0.7. I don't think everybody in the room thinks it's 0.7. Anybody else think it's something else? Anybody think it's 0.8? 0.6? 0.75? Okay, you're not thinking. All right. So everybody in the room thinks it's 0.7? Really? Okay. So let me ask you this question. When you use this ruler, how did you know to say 0.7? Why didn't you say 0.75? Why didn't you say 0.751? What made you stop? And that's what you need to know about. Significant figures come from somebody measuring something with an instrument. And significant figures include every number you're certain about, and you're certain because of lines, but it always includes the last number is a guess. You have to estimate it. You see that? So when you say 0.7, and what are these units anyway? These are not centimeters. What are these? What would you call that? It's metric. This is 1 what? I'll give you a clue. 1 decimeter. So you thought it was 0.7 decimeters. Now my question to you is, wait a minute, you said it includes all the ones I'm certain about. Does that mean that I would bet $100 that it's 0.7? Is that what you do? You bet $100 that it's 0.7? And if it was 0.69, you lose your $100? Is that what you're telling me? And so what I'm asking here is, does this include all the ones I'm certain about? Yes, because I'm not certain about that. How many am I certain about? None. But the last digit's always a guess, and you guessed this, didn't you? So using this ruler, measuring that line, the best you can put down is 0.7. You cannot put 0.75 with this ruler. Why not? Now, look at me right in the eyes. You cannot put 0.75 with this ruler because you're telling me that you were absolutely certain about the 7 and you guessed the 5. That is not what you did, is it? You couldn't be certain about the 7. You don't have lines to be certain about. So you can't put 0.75. But you can put 0.7. And so where do significant numbers come from? They come from the instrument, from you measuring something. Now let's turn it over to the next side. Find the side that has a lot of things on it, about this big. They're about this big. Let's try that. And you lay it down, you say, well, that's, ooh, man, that's a tiny bit, for me, it's a little bit over that. Let's see, 1, 2, 3, 4, 5, 6, 7. I think it's about 7, maybe it's a little bit more. And what are these units called? What are these little guys called? They're about this big. We're in trouble if you can't answer this question. What are they? Centimeters. Okay. Everybody see that? Now, it's the same line. So which one is it? Is it 0.7 decimeters or 7.1 centimeters? Which one is it? It's both. You can see what's happening here. If I use a ruler with more lines on it, right? Smaller units, I can actually give you more sig figs. This says I'm absolutely certain about the 7, and I guessed the 1. What about some of you? Did you put 7.1, or do you think it was right on the line? If it was on the line, you would have to say 7.0. I'm okay with that. You say 7.0, I say 7.1, I'm okay. Because I know that you and I had to guess that last number, didn't we? Even up here, if you said 0.8 and I put 0.7, I'm okay with that. Because I know it was a guess. The last digit's always a guess. How many sig figs does this have? 1. How many does this have? 2. Now, I have, I could have passed these out, but I didn't, sorry. I have one of these, and what I'm going to do is line it up, and I'm going to lay it here and try to get out of the way and magnify it. Okay? Whoops, I covered it up. All right, let's see if I can magnify that. Wait a minute. All right, there we go. Now what? Now what would you read this as? What do you think? Walker, what do you think? Give me a hit on that.
Probably 7.
7? All right. Now would you just write down 7 centimeters?
7.0.
You sure? Okay. All right, Patty, what would you say?
I'm like, from my angle, it's not exactly on the 7.
All right, so what would you say? Are you certain about 7?
No.
Are you certain about 6?
Yes.
Did you put 6 point something?
Probably 6.99.
Are you certain about 6.9?
Yes.
Okay.
Probably 6.99.
Okay. Okay, so let's take a look. Now, so what we saw here is that as I gave a better and better ruler, we got a different measurements, didn't we? You don't like that because in math class, that doesn't happen. 5 is always 5, isn't it? I don't think you liked it that it was 0.7, then 0.71, and all of a sudden 0.699. This is not a great ruler. See that? It's not a great ruler. But notice what happened here. I did get 3 sig figs, didn't I? If, Walker, if you thought it was on the line, what you would be required to do as a science person, rewrite 7.00, because look at the ruler. This ruler goes down to tenths of a centimeter, doesn't it? I have lines to be certain about tenths of a centimeter. Now, if you're certain about centimeters and you're certain about tenths of centimeters, you're still required to do what? You still have to guess the next digit, don't you? And Patty did a good job on there. You said, well, I'm not going to say 7. I think it's a little bit less than that. And you're both right. 7.00, 6.99, you're both right. Everybody get it? I'm okay. I mean, right now they're only off by 1/100th of a centimeter anyway. And that happens in science where we get people look at something, they don't always get that last digit the same. Now, so let's talk. Let's take a look at this again. Where do significant numbers come from? Why did I get 1 and then 2 and then 3 sig figs? What made me get a different number of sig figs? What was it? The instrument. When you're going to be doing some labs here, unfortunately, the first lab, I don't give it away, but the first lab, you're not allowed to use any measuring device. But then after that, you get to use measuring devices the whole year. So I can't give it away, but I'll tell you what it is later. But I'll show you what we have here. Here's an example. You might use one of these. All right, this is a graduated cylinder. And so give me a, let me call somebody. MSA, you can do it. Give me a typical reading. If you were going to use this instrument, pick some random number on there and say, oh, that's what I'm measuring. And give me something that might come from that graduated cylinder.
70 milliliters.
It is in milliliters. Go ahead. How many?
70.
70, okay. What do you think about that? And so I'm going to say that something got lost in the lesson. So let's start again. And let me ask, all right, Lily, what do you think?
Well, can you zoom out a little bit?
Can I do what?
Zoom out.
Oh, zoom out? Actually, that's all you need to see. I can zoom out. It looks like this, but really what you want to see is how many lines I have. All right, give me one. Somebody else. All right, Parker.
Wait, do you just want to know?
Give me if I were to use this graduated cylinder, give me a typical reading that might come from this thing.
70.00.
Okay, let's take a look. All right, that's two people's opinion. All right.
Jeffrey.
No, how about Colleen? Colleen, give me a typical read. See, 3 in a row. Tic tac toe.
70.10.
Boo.
7.10. Okay, let's take a look. Anybody else want to guess? Yes, Walker.
Just be 70.0.
Yes.
Now, what I like about Walker is after Patty figured out how to read this ruler right, he said, you know, the answer I gave, I should have said 7.00. So I think you learned something there, didn't you? Let's take a look. Let's take a look at this right here. Can you be certain about the tens place? Do you see a line for 60, 70, 80? You can be sure about the tens place. Do you have lines to make you certain about the ones place? Then you can be certain about the ones place. When do you start guessing with this graduated cylinder? Tenths. You cannot go beyond tenths. You cannot go, this one's not enough sig figs, sorry. This is too many, ding, ding, ding. Okay, you're correct. Now, I don't know why everybody was so hung up on 70, but how about right here? Let's say it was right about here. Let's say it was right there. It'd be 65.5. 65.5. So I know when I pick up this instrument, and you're going to have a lab eventually where you have to use sig figs. You pick this up, you better give the right number of sig figs. And everybody see that how it works? Now watch this. There you go. Uh-oh. That's got white paint on it. So I'm going to put a black background on it. All right. Somebody, let's do these. Oh, you already did it. Let's do this row. All right. 1, 2, 3. Give me a typical reading using this graduated cylinder. Go.
7.5.
Boy, we're hung up on that 7 thing. What is it?
7.50.
7.50. Next.
6.98.
Next. Say it again. Well, it can't go past 10.
Yeah.
Oh, you didn't know that.
And you have to please.
You didn't know that. But it can't go past 10. So give me another one.
9.99.
All right, what's interesting is all three people gave me the same number of sig figs. Are they correct?
Yes.
Let's take a look. Can you be certain about the ones place? Yes.
Yes.
Do you have lines for tenths place? But you still have to guess what?
Hundreds.
Hundreds. Ding, ding, ding. So all three of you, good job. All three of you had the right number of sig figs. I wanted you to understand, let's do one more. We might, even though I have electronic thermometers, we might use this. I don't really like getting the mercury thermometers out, but we could. Where is that guy? Whoops. Where is he? You can't see it, can you? No. Okay, I'll tell you what. I'm gonna have to magnify that thing. Wow. All right. Wait, I want to magnify it, and then I'll tell you what. I'll have to turn it a little bit. Let's see if I can do that. There. Ooh. Can you see that?
Barely.
I know. That's why I don't even like using these, but
0.0.
no, it's bigger than that.
20 point, yeah, like 23.
20, 23.
22.9.
What were you looking at?
If you said 22.9, I'm okay with that.
Yeah.
Who else said another one? 23.0. I like that. Because now you're catching on, right? You're catching on that if I'm certain about the ones place, tens place and ones place, then I can only go to tens place, can't I? Now, if you understand that significant figures come from the instruments you use, then it's not a game. It's not a game anymore. So when I go back to this last page, let's find out how many sig figs a measurement has. Why do scientists need to have rules about sig figs? Okay, now watch. This is going to make sense to you, I think. If you're there and you pick this up and you know the rules, you say, I have all the ones I'm certain about, plus one guess, then you're going to write down the right number of sig figs. I get it. But what if you're reading about somebody else's experiment? You weren't even there. You don't know if they picked up this or this, but you do. How will you know which instrument they picked up? How will you know which instrument they pick up? If you see a reading that says 61.5, okay, it wasn't this one, right? And so I can actually tell, if you say, for example, look at this reading here, 0.02. Now, the only thing I didn't like about this author, they didn't put like a unit afterwards. That's all right. So 0.02, were you there? Were you there when they measured that? No. But you know what you do know? You know that they did not have a really good balance. Their balance, and let's say this is centimeters. I'll make it easier, right? 0.2 centimeters. What did that ruler look like? It would look like this. Here's 0. And here is, oh, that's 0.02, right? Here is 0.1, 0.2. See that? Their ruler had to look like that, and the measurement was like this. 0.02? That's what it is. I'm sorry. Oh, no wonder. I thought, man, okay. Thanks for telling me that. I'm sorry. Okay. All right, so let's look again. Now, you weren't there, but if I see 0.02 centimeters, I know that they guessed what? They guessed what place?
2.
The 200ths, right? So the ruler must have been something like this. They had a 0, they had a 0.1, and a 0.2. And that's all the lines they had. They didn't have any other lines. And here's 0.05. This is 0.02. And maybe some of you thought, oh, I would have said 0.03. Oh, I would have said 0.01. I know that. But here's what the thing is. By knowing these rules that I'm going to show you, I can tell you what kind of instrument you used, even though I wasn't there. If you and I know, if everybody in the world, all the scientists in the world, engineers, if they use the same rules, I know exactly what you're talking about. I can also tell you how confident I am about that number. How confident are you about that number? It could be 0.01, couldn't it? I could be off by 150%. And so what we see is that the number of sig figs have a great deal to do with how confident you be in that number. So here are my rules, okay? They're not even my rules. I'm getting rid of all the rules that tell you when something's not significant. And we're just going to learn 3. And it's going to be easy, all right? It's going to be pretty easy. All right, here we go. Rule number 1. If you see a measured number, and the number is not a 0, it's in. You have to call it a significant digit or significant figure. Same thing. So watch. Rule number 1, go over here. I'm going to put a single line there because that guy's in the club. Let's do number 2 for rule number 1. You're in the club. You're in the club. You're in the club. Look at this. Wait, is that fair? You're going to do all 10 of them with just rule number 1? Yeah, that's right. There we go. Now, is it possible that I just reinforced rule number 1 with you? I think I understand rule number 1. If it's a measured number and it's not a 0, I'm in. Everybody remembers that rule. Got it? I don't care if you're a scientist in Russia and I read your work. If I see a measurement and it's not a 0, it's in. That's a significant figure. The next one, and if you become a famous scientist, don't say this out loud. I made this up. I call it the Oreo cookie rule. Okay, you don't have to call it that. Somebody say, what? Okay. If you're a 0 and you're trapped between 2 significant digits, like 2 non-zeros, if you're trapped between 2 non-zeros, you're in. Okay? So just like the cream in the Oreo cookie. Okay. So let's take a look. Let's see if I can find a trapped 0. Are these zeros trapped between 2? No. No. Oh, there you are. I'm going to put 2 lines there to remind me. That's rule number 2. I'll never ask you what rule it is. You get it? I'm just going to put 2 lines there to remind me. That's by rule number 2. Hey, look, here's one. Oreo cookie. Oreo cookie 0. No. Only 1 wafer, not 2 wafers. Here. Nope. 1 wafer. Here's one. Nope. Uh-oh. Oh, that's triple stuff, isn't it? All right. Are you okay so far? I don't think anybody's going to forget the Oreo cookie 0 rule. Get it? I have one more. It's the only one you have to pay attention to. You're not going to forget the first 2. If you are a trailing 0, now listen to me. If you're a trailing 0, it means trailing a sig fig. I'd never said trailing a decimal until right now. No, not trailing a decimal. If it trails a sig fig and there's a decimal in a number, then you're in. Let's try it. Do you see any trailing figures coming after the 2? Then I'm done. You see any zeros trailing the 2 here? Yes. Are you in? Maybe. Do you see a decimal somewhere? Well, then you're in. I don't have any trailing zeros. Is this a trailing 0? Is it coming after a sig fig? It comes after the 1, doesn't it? Do you see a decimal? Then you're in. Look at these guys. Are these trailing zeros? Yes. Do you see a decimal? Then you're not in. Go over here. Are these trailing zeros? Do you see a decimal? Then you're in. You're in. You're in. And I'm done. So now I just go count. Ready? How many total sig figs does this guy have? 1. How many here? 2. How many here? How about here? How about here? Okay, now listen to me. I have something to tell you about this. Scientists don't want to be confusing. They say, hey, gotcha. You thought it was 4 sig figs. Hey, it was only 1. They don't want to do that. So if I did have a measurement like this, and I wanted to tell you that I did not have a very good instrument, I wouldn't mess around with you guessing that these might be counted. I would do this. I'd put it in scientific notation. Now, how many sig figs are you certain? How many? How many sig figs now? 1. Now, you're telling me something about that instrument. There's only 1 sig fig. It was a 5. So you had an instrument that looked like this. 0, 10,000, and that's all the lines you had, and 5,000? You see? Bad instrument. It was not a very good, it wasn't an expensive instrument, was it? What about this person? How would the scientists write this to make certain to tell you, you can trust this guy. This has 4 sig figs. How would they write it? .000 times 10 to the third. You get that? I'm telling you, I didn't even have to guess until, look at that. I had a really good instrument. 4 sig figs. How about this guy? I don't want to write this in scientific notation, but how many sig figs here?
6.
1, 2, 3, 4, 5, 6. 6. How about here? These are not trailing zeros. They don't trail the 5. Only 1. And here, 4. And here, 5. What do you think? Pretty easy? Now, it's not just a game. I understand what your instrument looked like to get that number. You and I know this. If we know about measurement, we know what you're talking about. In almost every case, the more sig figs, the more you can depend on that number. You get that? And we have some other words to talk about. Like, for example, what if you have a great expensive equipment? What if you don't calibrate it? You have a great instrument, but what if you don't tell the instrument what the numbers are? It's called calibrating. Anybody here ever calibrated? You know what calibrating is? What's calibrating?
It's giving it a reference point.
Say it again.
It's giving the instrument a reference point by which to measure everything else to be set to
Right.
0.
We have to have some kind of a standard, don't we? We have to have something we know we count on being true, and we got to make sure our instrument reads that. When we say that's 5.00, it's going to read 5.00. You guys are going to use an electronic balance in here, and it goes down to hundredths place. Now, when we bought that balance, I have a box, and you'll see it in there. They gave me this thing called a standard mass, and I have to protect it. I don't want it to be damaged. It's not just 200; it's 200.00. That's how accurate that thing is. So when I put it on the balance, it needs to say 200.00. If it doesn't, I have a button I can push, and I tell the electronics, this is 200.00. And now it knows. See that? That's called calibrating. You're trying to set your instrument to a known that you have. Now this is the stuff I'm talking about. If you were to stay in science, go in the medical field, whatever, you'll see these things all the time. They come up all the time. It's just that you don't see them a lot of times. You're not going to see them in middle school. They can't understand this stuff. Elementary, no way. They're not going to do it. You get in the big boy and girl world out there, you're going to find out that this stuff is really, really important. All right, let's see. Let's not do that part. Now let's do the next thing. Let's turn it over. And if you have your calculators with you, we're going to do something that's kind of weird. So get your calculators out, and I'd like you to please only do what I ask you to do, and I'll tell you what we're doing, okay? What I'd like you to do is we're going to start calculating with our calculator, and then we're going to write down the answer. You say, well, that's not new. Well, this is going to be a little new to some of you, okay? I want you to put this in a calculator, and then I want you to write that over here. Write the calculator answer over here. And we're not going to do all of them. We're going to save a little time. Let's do number 1. Let's do number 2. And let's do number 3. And then I think we'll do, let's do number 6. How about that? So I want you to do number 1, 2, 3, and 6, and just write down what the calculator has over here. Okay, so do the calculations and write it in the parentheses. So 1.35 times 2.467, write that in the calculator, answer right there. One, 2, 3, and 6. I want to thank you, by the way, for doing this, because you're saying, wait a minute, I'm not going to learn anything by putting this in a calculator and multiplying or adding. Oh well. I want to thank you. You're doing it anyway, and I'll let you know why we're doing it. Okay, 1, 2, 3, and 6. Patty, you have a calculator?
No,
Okay,
I really don't know what
all right. All right, here we go. Tucker, tell me what your calculator said the answer number 1 was.
3.33 times 10 to the 0.
3.33 times 10 to the 0. Is that what it said? Okay. All right. And let's see, Kinsley, what's your calculator said number 2 is?
24.6.
24 point what?
0.64
And that's all?
times 10 to the 0.
Well, it can't be times 10 to the 0, but does it say E? You don't have to have these in scientific notation. You don't have to. But it can't be 24 times 10 to the 0. That's all right. And number 3, Sarah, what's number 3 say?
53.21.
53.21. That's all it has. Okay. And number 6, Ben, what's number 6?
Let's go Ben.
33.51.
And that's it? Everybody got it? Is that what everybody got? All right. First of all,
Wait, Ben.
Number 6.
Or 3.51.
oh, this one can't be. What's the answer again?
3.351.
3.351? Is that right?
Yeah.
Okay. Now, if you, yeah, go ahead.
For number 2, I got a lot more.
Okay, 24.64,
2857.
wait, after the 4 is what?
28571.
All right, is that what you had? Oh, you didn't want to tell me? You thought you should stop? Okay. Yes,
Also the same thing as number 1.
number 1's what?
I don't know, but I had 3.33045.
Say it again, 333.
3.33045.
All right, so the people that gave me these answers, what made you stop? Not give me the full thing.
Because it's 3 sig figs. Yeah.
I never said that. I never said that. Okay, now, so the lesson is this. Sometimes in science, you measure numbers, and now we know how to measure it properly. But then sometimes you have to do calculations with measured numbers. Now, this is where I need you to really listen, because you will never do this in math class, but you have to do it in science. Now, there are people who are very, very mathematical, and they love statistics. Statistics is a branch of mathematics that talks about, how much you can trust numbers and things like that. And anyway, they, not me, they said, you know what? if you're gonna start doing calculations with measured numbers, you have to have a set of rules that nobody else uses. The math teacher will never use these rules. If you're in that math class and they have this on a test, you better write that down because they expect that. Now, they expect that because they have a world of perfect numbers, and that's what you should have gotten. But let's take a look up here. The statisticians say when you are messing with measured numbers, if you multiply or divide, you must round to what? You must round it to, what does it say? The least number of sig figs in any of the factors. Now watch. Quickly, how many sig figs does this have? 3. How about this one? Which one's the least number?
2.
Okay, now watch.
Sorry.
If you are going to round this number to 3 sig figs, do you ever look at the 4th figure? I'm looking at everybody's face. If it said round to 3 figures, do you ever look at the 4th figure? You have to. You have to.
Never.
You have to.
Oh.
Now, underneath my finger is the 4th sig fig, and if it's 5 or higher, this guy's changing. Is he changing? Ooh, nope. Nope. Okay, now I'm ready to write the answer down. 3.33. Now, see, your calculator does not know what a significant figure is. You get it? Your calculator's so dumb, it didn't know he was supposed to write 3.33 in science class. Here's another thing your calculator's so dumb about. It did not know what a meter times a meter was. So what is the answer? 3.33 what? It must be calculating the area of something, isn't that right? A square meter is an area. Let's do the next one. The next one is a division problem. The good news, multiplication and division has the same rule. We have to round to the least number of sig figs. So how many? How many right here? 4 here. What's the least number? 2. When you round to 2 sig figs, do you ever look at the third one?
Yes.
You have to. I'm big enough. I am big enough. Okay. Now see, you would never do this in math, and that's why you don't like it. Well, if I do that in math, they're going to mark it wrong. They do not use measured numbers. Now, what's a meter squared divided by a meter? I'll give you a clue. It's the same as x squared divided by x. There we go. All right, a little bit longer. We're almost done. The next one, I didn't do this, but some statisticians said, you know, it'd be nice if they had the same rule, but no, we've studied this. And when you add or subtract, you have to round your answer to the least number of decimal places. It's not sig figs at all. Watch. How many decimal places? Hundredths place, tenths place, ones place. Ones place is a decimal place. I know you don't think that because your math teachers teach you everything to the right. Everything's a decimal system, isn't it? Ones place, tenths place, hundredths place. What's the least number? Ones place. If I round to ones place, do I ever look at tenths place? You have to. Not big enough. And so what's a milliliter plus a milliliter plus a milliliter? Milliliter. Thank you for not saying cubed. Okay, it's just milliliters, isn't it? All right, hey, you did a good job today. Let's see. Hey, don't forget, the sun doesn't shine every day. So if you have a chance to get out there, all right, if you want to be a little strategic about it, you could look it up, solar noon, and you might only have to get out there for about 10 minutes. You might be able to talk to one of your teachers and let you out for about 10 minutes.
Just math class, just entire number.
We've already done it, but
Sarah, you have 5 minutes, go.
Better hurry.
I have a study hall.
You better hurry.
I have study hall. It's not till 1:11. Bye guys.
Are you trying to actually like miss math to go do that?